All right, the next thing we have to do is an example on work, example 6. So, work in a physical sense, um, whenever you have some sort of field that describes a force, like the gravitation field, electric field, magnetic field, so on and so forth, um, you can you can ask how much work is performed by a force if we know its force field. Well, the amount of work performed or the work done by a force is the line integral over that path. So, for instance, you can imagine taking an object like a ball, holding it up above the ground, and letting go. When you let go, that ball will begin to fall, and gravity, the gravitational field, is doing work because it's pulling that ball down. A lot of times in physics types, problems of a physical nature, sometimes we want to know how much work do we have to do or a machine have to do to overcome a force. So if how much do I have to pull on a rope to lift something up? Well, in that case, we are doing work against the field. So the difference between who does the work is really the difference of a minus sign. Because if we take a ball and we drop it, or we can imagine or think of running that process in reverse and the ball being lifted back up to where we initially dropped it from, the same amount of energy is exchanged. So the amount of work is the same, but it's opposite in sign because the direction of the path is different. One time the ball is going from top to bottom, the other time the ball is going from bottom to top. So the wording of a problem can influence whether or not you have this minus sign in front. If you are asked to do or to overcome a force, then you want to know how much work do you have to do. All right. So let's take a look at example 6. Determine the work needed to be performed against this force to move a particle from the point P to the point Q along a path C parameterized by this for t between 0 and 1. So they give us 2 points here. Notice that if we plug in the endpoints 0 and 1 into this, we'll get back those values. So in this case, it's the work needed to overcome the force. So in this case, we're going to go ahead the negative. So this would be the work needed is negative the integral over the path C, which is parameterized from 0 to 1. So our force field is x squared, comma, negative z, comma, negative y, z to the minus 1, dot dr. So negative integral 0 to 1. We'll replace x, y, and z with what they are on our path. So this tells us x is t squared, y is t cubed, and z is t. So this will become x squared, so t to the 4th, minus z, so minus t, comma, minus, let's see here, we'll have to simplify this. Let's do it in steps. We'll have negative t cubed, t to the minus 1, dotted with the derivative, which is 2t, 3t squared, and 1 dt. So I'll go ahead and absorb this negative into this dot product. So this will be, let's see, we'll have negative 2t to the 5th minus, nope, double negative, it's going to be plus 3t cubed plus, this is going to be t squared dt. A little bit of work here, pun intended, and we should be left with the answer 3/4. So the main thing here that you have to just be aware of is that whenever you hear work in a problem, they are talking about a line integral, and then depending on how it's worded of who's doing the work, or are we overcoming the work, or excuse me, are we overcoming this force, or do we want to know how much work is done by this force? Then it's just going to be the line integral over our path.